Hey everyone, and welcome to another episode of That Salty Chef. Today we're making pizza, and not just any pizza, but leftover Thanksgiving feast pizza, my favorite pizza of the year. Now, the start of any good pizza is the crust, the foundation, and that's so important. So I'm going to show you a little trick that kind of saves us a lot of time. We're not going to make our own crust. We're going to use this crust. So let's get this started here. Got to get it open, got to get it preheated or pre-cooked for about 8 minutes. So we're gonna open it up, roll it out on this pizza stone, this baking stone here. So let's get that ready. And you know, when I think of crust, I don't just think of pizza. I also think of the layers of the earth. I think of marine geology, and of course that great area of science pretty much invented by a gentleman by the name of Alfred Wegener, plate tectonics. So as we cook here today, we're going to talk a little bit more about the crust and plate tectonics. So all right, our dough's ready. Let me put this in the oven. So come on over here with me. We'll stick it in the oven, set the timer for 8 minutes, and then as that cooks, we'll talk more about plate tectonics and crust. Okay, in addition to talking about crust and plate tectonics, I want to talk a little bit more about the pizza we're making. So what is going to go on this pizza? Well, everything from our Thanksgiving feast. We have some ham here. We have leftover turkey. This is my favorite, a squash 3-cheese casserole, string bean casserole, mashed potatoes, we got stuffing, I cut up some ham here, we got to have the gravy, and cranberry relish. Everything is going on this pizza, and I will say it's not going to be the prettiest pizza you've ever seen, but it's going to be so good. So we got about 6 minutes or so left. So let me tell you a little bit more about crust. So if we were to cut the earth in half, right down the middle, we would see that the earth is made of several different layers, 4 major layers. We have the inner core, which is solid and very dense. We have the outer core, more of a liquid form. We have the mantle, very molten. And then we have the crust. The thinnest layer by far is the crust. If we compare the earth to an apple, the crust would be about the thickness of the skin of an apple. Now there's more than one type of crust. There's actually 2 types of crust. There's the continental crust and the oceanic crust. The oceanic crust is somewhere between 7 and 10 kilometers thick. It's made up of dark minerals, very dense. One of the main rocks is basalt. Where the continental crust is somewhere on the average of somewhere between 35 and 40 kilometers thick, made of lighter colored minerals. Granite is a great example of this type of rock, and it's less dense than the oceanic crust. The crust of the earth is a very dynamic place. It's moving around. It's not one solid piece, but it's actually broken down into many smaller pieces that we call plates. Not a dinner plate, but tectonic plates. Some of them are mainly oceanic crust, some of them are mainly continental crust, some of them are a combination of both. And these plates are constantly moving around the surface of the earth. Now, down the middle of the Atlantic Ocean, there is a boundary where 2 pieces of crust come together, and they're moving apart from each other, and they're moving apart from each other at roughly somewhere between 7 and 10 centimeters per year. So about that much further apart every year. So it's a pretty slow process. But each of these plates, all around the outside edges, are boundaries. And there's basically 3 types of boundaries. There are divergent boundaries, where 2 plates are moving apart from each other. There are convergent boundaries, where 2 plates are moving towards each other, and then transform, where they're moving sideways to each other. Now, a lot of really interesting things happen at these plate boundaries. When 2 plates are coming together, a couple things can happen. If this is oceanic crust coming towards continental crust, remember this one is denser, it's going to go underneath the other, and it's going to cause something called subduction is going to occur. This is where we have the ultimate in recycling. The crust is going to get pushed down into the mantle, melted down, and eventually will become crust again. Also, quite often where this happens, this crust here gets pulled down a little bit, and we have really deep sections of the ocean called the trenches, the deepest spots in the ocean. So that's when a oceanic crust comes together with a continental crust. Now, when two continental crusts come together, both the same density, they come together like this, and they collide, and they push up, and this is where we find mountains. And an excellent example of this is the Himalayan mountains, which is where India slammed into the Asian plate, forming the Himalayan mountains. All right, so I know what you're thinking. You understand the Earth is covered in plates, but how many of them are there? Well, there's about 15 major plates and possibly as many as 41 minor small. Oh, hold that thought. Our crust is ready to pull out. Get our gloves on. There we go. There's our crust. So we're getting, all right, now it's time to make our pizza. So the first thing we're going to do is we're going to start with a little bit of mashed potatoes here. We add some of this a few spots, kind of mix it around, and it doesn't have to cover the whole pizza. Now, this idea of the crust moving around, very dynamic, we've talked about, and we understand that. And I mentioned this term plate tectonics. So how did all this start? Well, it started with a gentleman by the name of Alfred Wegener, a German meteorologist, studied the weather. He made a few observations. He noticed that some of the continents seemed to fit together like a jigsaw puzzle, and he thought that was interesting. He also noticed that there were fossils on one side of the dinosaur fossils on one side of the Atlantic in South America that matched fossils found in southern Africa. He said, that's interesting. Another thing that he noticed was coal deposits in Antarctica. Now this was really kind of something unusual because coal deposits come from tropical rainforest or tropical forests with lots of primary production, lots of growth of plants, rainforests and stuff like that. And all that dead material build up over time and form these layers that get buried and eventually turn into coal. Well, that couldn't happen in Antarctica. It's too cold for that kind of environment. So that led him to believe that maybe Antarctica wasn't always at the southern pole. One other piece of evidence that he found, string bean casserole is my favorite, was that there were mountain ranges that seemed to be the same age, same size, same composition on different continents far away from each other. Maybe at one time they were all together. So this was all evidence that Alfred Wegener used to come up with the theory that he had, the theory of not plate tectonics, but continental drift. He said the continents are drifting around. He published it, he was excited, but unfortunately nobody believed him because they asked the big question, how does this happen? And honestly, Alfred Wegener said, maybe the tides, maybe the gravity of the moon pulls these plates around. He really had no idea. He was a weatherman, not a geologist. So the geological community pretty much ignored him. So it pretty much wasn't until after Wegener's death that other scientists started to make some other discoveries in the ocean. One was that they discovered this mid-ocean ridge that runs through all the world's oceans. Very volcanic, very active, and they believed the plates were actually moving apart here. So this was key. They had some evidence that supported this, magnetic anomalies for one. They looked at core samples, aging the sediment, the thickness of the sediment, a lot of things like that, and they realized that as we move closer and closer and closer to that rift, the plates, the earth, the crust was younger, younger, and younger. That indicated they were moving apart. And this actually backed up Wegener's theory, even though I think by this point Wegener had already died. Another big piece of evidence had to do with what was happening inside of the earth, these convection currents, where the very hot core was pushing mantle material up. It was rising through convection currents. And remember, warm air rises. That's why you get down low if your house is on fire and there's smoke all over the place. You get down the floor and you crawl. because the smoke rises and the cleaner air is down below. But anyhow, so you have this hot magma material rising, hits the top of the crust, the underside of the crust, and starts moving sideways, literally pulling the crust apart from each other. And that was the mechanism. So we called this the theory of seafloor spreading. So that with the theory of continental drift basically were put together, and the famous theory of plate tectonics came about. So that's how it happened. All right, so I'm looking at this pizza. I think we are almost ready to put it in. So I'm going to add a little bit of gravy. Just a few dollops. Okay, so I'm going to add some cranberry sauce. Clean off my spoon here. So add a little bit of this. And I think we're ready. Take a look at this. Does that not look delicious? So, all right, last thing we have to do is we got about 6 more minutes in the oven. So, get my gloves on. Get it in the oven. Set our timer for 6 minutes. And while we wait for that, I'll let you think a little bit more about the Earth's crust and the layers of the Earth and the theory of plate tectonics. All right, the pizza, I just pulled it out of the oven and it looks perfect. Take a look. Now we just need to let it cool down a little bit and then it is time to eat. So everybody, thanks for watching.